Welcome to another coding tutorial, and in today's video, I'm going to show you how to create this glitchy visual effect using a technique called pixel sorting. You've probably seen this kind of streaked and broken looking aesthetics before because it's one of the most recognizable signatures of glitch art. It is created using a technique called pixel sorting, which was made popular by the artist Asendorf when he released his work and also his code back in the early 2010s. And since then, it's been reimagined and remixed in a ton of creative ways. And I'm especially excited to be sharing this tutorial because only a few months ago, I had a chance to participate in a week-long workshop with Kim when he was in Bangkok for Complex, a solo exhibition at the Goethe Institute, Thailand. There are many ways that we can sort the pixels, by columns or by rows, based on the brightness that is above or below the threshold, and you can mix and match each of these ones. But for the purpose of walking through the algorithm, we're going to be sorting by column and use the brightness that is above the threshold. First, we go through each of the column in the x direction, and then in each column x, we look through each pixels in that column, so down the y-axis. We check to see if there's a pixel that meets the brightness requirement, and if there is that first pixel, we set the y location as start y. Then we continue down the column until that requirement is not met anymore, and then we set the previous pixel's y location as ny. And then once we have the sections that we need to sort, we basically will be sorting them using the built-in JavaScript function sort. And then we replace the original segment in the image with the sorted pixel values. And then we continue down the column to see if there are more sections that we need to sort. And that's it. So I'm going to start by uploading the image, and the image I'm going to use is actually the original image that is in Kim's GitHub's page. So it's going to be this mountains image here. So to upload the image, you want to come to this arrow here, click the plus sign, and then click upload file. And then you want to drag and drop your image file in here. All right, once your file is uploaded, what you want to do is you want to create a variable. I'm going to call it img, and then we're going to write a function called preload. And preload allows us to preload the image onto the sketch before we start running the program. And what we're going to write in here is we're going to set img to be equal to another function called loadImage. And then inside here, we basically just need to write the name of the file inside a quotation mark here. So it's going to be mountains.jpg. And then I'm going to click run just to make sure it's uploaded properly. Perfect. And then now what we want to do is we want to display the image on the canvas, and we can do that using a function called image, and it takes in 3 arguments. The first one is the name of the file, img, and then the second and the third are going to be the x and y coordinate of the top left corner of where you want to place it. So let's do 0, 0. Let's click run. All right, and as you can see here, we only see the cloud, and that is because the image is really large. What I'm going to do is that I'm going to resize the image, and we can do that by using the method resize. So what we need to do inside setup here is put the name of the file, img. Actually, I'm going to do it before create canvas here, and then resize. And in here, what we can do is, let's say we do 400 by 400. You can see that, I don't know if you can tell, but actually the image is distorted. So I don't want to do that. So what we can do is we can just put in the desired width, which is 400. And then for the second argument, you can put in 0, and it is going to resize it proportionately. All right, and then now, actually I want to make it 500. Let's make it a little bit bigger. Okay, as you can see here, it doesn't fit our canvas size anymore. So what I actually want to do is I actually want to set the canvas size to be the size of the image. So let's just do img.width and then img.height. And I just want to show you what that size is right now because we're going to be using it in a little bit. So you can see that it's 500 by 333. Next, we're going to use the function called loadPixels. So let's look at the documentation page. loadPixels loads the current value of each pixel on the canvas into the pixels array. So there's loadPixels here, but if you come here, let me just put in loadPixels, and there's p5.image.loadPixels, which is a little bit different because this one loads the current value of each pixel in the image into the img.pixels array. So the first one, if we just call loadPixels, it loads the pixels off the canvas itself, but img.loadPixels loads the pixels, or put the pixels inside a pixels array called image.pixels. So the difference is between the canvas or the image itself. We can do either one because right now we're displaying the image on the canvas that is this exact same size, but I think it's safer to just do it on the image. What I'm going to show you so that you know is, how about I show you, let's do img. Actually, let's do it before image here. img.loadPixels. And then if I click run, you don't see anything happens because it basically just loads that value and put it inside an array called img.pixels. So I'm going to print. I'm not going to print the array itself because it's going to be large, but I'm going to show you one, that it exists and its length. So right now its length is 666,000, and that is basically 500 times 333 times 4, I believe. Yes, and that is because each of the pixels has 4 values, R, G, B, and alpha. So red, green, blue, and alpha. So for each pixel, it has 4 values. But why did I went into the whole loadPixels thing on the canvas? And that is because, let's say that we do loadPixels and then just print this. It's not 666,000 anymore, right? It is 5,994,000, and actually this is 9 times larger. And that is because if I print pixel density, it gives you 3. So what is pixel density? So pixel density, as you can see here, 3 for my screen, is the ratio of the number of physical pixels on your screen to the canvas pixel. So for 1 pixel that I have, it has basically 3 by 3 additional pixels, so 9 additional physical pixels. So for higher definition screens, the pixel density usually is higher than 1, which makes it a little bit more difficult when you do some pixel calculation. So you can either make sure that you know what is your pixel density and multiply that in all of your calculations, or you can set your pixel density to 1. Basically, you can just do pixel density and then just provide the number of pixel density that we want here, 1. And now it's 1. But in this case, because we're going to be using img.loadPixels, this doesn't actually going to matter, but I just want to show you so that you know the differences. So we have loadPixels and we also have updatePixels, which means that we can actually update the pixels array. So if I do img.updatePixels, you don't see anything different because we have not updated the pixels array yet. So why don't we do that? First, set pixels, img.pixels, right, of index equals to 0. So what is index? Because we're dealing with a 2D picture here, but the pixels array is a 1D array. Actually, we need to use this calculation. Let index equals to x plus y times the width of the image and then multiply by 4 because there are a total of 4 colors for each pixel, sorry, well, not colors, so RGB and then the alpha value. So by doing this, we can convert from a 2D XY coordinate to the corresponding 1D array. And how about I set x to be equal to 0 and then y to be equal to 0. So this point should be 0, 0 here, right? And if I just do index like this, it's just the red one, right? So what we want is we want to do it 3 times. So 1, 2, 3 more times. And how about we set transparency to 255 and then let's click run. All right, can you kind of see here? Small, but you can see that there's a black dot here. And if I change this to red, it is red. And if I do transparency to 0, you would not see the change, right? And last but not least, if I change the position of this to 100 by 100, it should change the pixels that is being updated, right? So it's right here. All right, so this is how we're gonna be getting the pixels values inside the pixels and then updating it when we sort the pixels. I'm going to create a variable called, a Boolean variable called sorting done, and I'm going to set it to false first. And then inside draw, we're going to set a conditional statement that says if sorting is not done, then we're gonna do all of this. And actually, because we're doing this in the draw loop, we can just put in no loop because it's not animated and we just need it to run once. And then inside here, we're going to use a for loop that goes from x equals to 0 to x less than the image width, right? X plus plus. We're gonna go through all of the columns in the x direction, and then we're gonna write a function called sort column. Then we're gonna provide x as an argument. So that's the whole logic, the bigger picture. Now comes the fun part. We're gonna be writing the sort column function. Function sort column. And we're gonna put in x as a parameter here. First, we need to go through each of the pixels along the y-axis, right? To find the start y and then the end y. So we're gonna be using a while loop actually. So while y is less than img dot height, right? So until it hits a conditional statement, we're gonna keep calling this. So what are we gonna call? First, we want to set y to be equal to 0. Then we're going to use a conditional statement that says if the brightness is greater than the threshold, right? So we need to write what brightness is and then set what threshold is. So let's set the threshold. Let threshold, so how about we set the color, the brightness value to be 127 half, and then we can change this value as we go. Then now, what is brightness? So we need to check the brightness of the pixels values, right? So first, what we need to do is that we need to use the same calculation, index, to find the index inside the pixels array. So index equals to x plus y times img dot width times 4. And then we're going to find the value of the red pixel to be equals to img dot pixels of index plus 0, right? And then for green RGB, green and blue, we don't need alpha. For brightness, is going to be index plus 1 and index plus 2. And then next, we can use the function called brightness, which is built in to p5 to find the brightness. So bn is going to be equals to brightness of this color R, G, and B. All right, so we have brightness, we have threshold, and once this condition is satisfied, then we break out of the while loop. And then if not, we just increment y. And then once we break out of this while loop, it means that we have found the starting pixel, right? So what we want is we want to set start y to be equals to that y. So that's going to be the position of the first pixel that we're going to sort. Then we're going to do a very similar thing here to find the ny, right? But instead of this conditional statement, right, we're going to do the opposite. We're going to check when the condition is no longer satisfied. So when brightness is less than or equals to the threshold, we break. But instead of setting the y location of that specific y, we're going to set ny to be equals to y minus 1 because the previous one is the one that actually still satisfy the brightness requirement, right? Okay, so still with me? Perfect. And instead of just ending here, this is one section of the pixel that we need to sort. So what we want to do is we want to also actually create another while loop that says while y is less than img.height, it's the same, right? Because we want to go through after the first section just to see if there are more sections. So we're going to put all of this and nest it inside here. Now, the next thing is after we found each section, right? Now we want to sort, basically. So we need to write a conditional statement that says if start y is less than ny. This is just to check to make sure that in each of that section there's at least two pixels to sort. Once that condition is satisfied, then we're going to start sorting. But to do that, we're gonna put the pixels in that section inside an array. And I'm going to call it, how about sorting array? It's gonna be empty at first. And basically what we want is we want to use a for loop that goes from let I equals to start y to I less than or equals to ny, right? I plus plus, and we're going to be pushing stuff inside here. But what are we going to be pushing? We're going to be pushing or adding the color of those pixels, right? So we're going to go back to our trusty equation for the index again. So index equals to, so it's x plus y times img dot width times 4. But instead of x here, no, instead of y here, we're going to use I, and then we're going to find what the RGB values of that pixel is. So R is going to be img.pixels of index plus 0. And then RGB is going to be just like this, right? And then we're going to add it inside here. So color of R, G, and B. And then now our sorting array has all of the color information. Now we're going to start sorting. We're going to be using the sorting built-in function that is part of JavaScript. And that is going to be sorting array. So we're going to put the name of the array that we're going to sort and then just put in sort. And then the syntax is going to be parentheses A, comma B. We're going to be comparing between A and B. Then we're going to be doing brightness of A minus brightness of B. So basically what this does is that it's checking between the values of A and B. If this values or this calculation is negative, then A will come before B and vice versa. By using this specific equation, it is going to be sorting from dark to bright, because if brightness of A minus brightness of B gives a negative value, it means that A is darker than B, right? Then this will be negative, and then A will come before B. But if you want to sort from bright to dark, basically you just swap between this. So it would be brightness B minus brightness A. All right. And then next, once we sort, then we just need to put it back, right? Back into the image. So what we're going to do is we're going to use the same for loop actually. And then we're going to declare one more variable. Let's call it C. And C is going to be a value of a pixel inside the sorting array. And it is going to be at the index I. And then we're going to subtract it by start Y, because the sorting array starts at 0, right? And I might be something that is not 0, probably not. And then so that's why we want to minus it by start Y. And then what we're going to do is we're going to set img of pixels of index plus 0 to be equals to the red value of C. And we're going to do that for green and blue, RGB, green and blue. And then how about for safety, we're going to set the brightness as 255. All right. And the last thing to not forget is inside this big while loop, which is, let's see. Yeah, we want to increment Y, right? When we are finding each of the sections, the new sections. All right, let's try it. Okay, no error, but we don't see anything. How about we try to change the threshold a little bit? Let's do 80. Nice, all right. Do you see that? So if we do even lower threshold. Perfect. That's really nice. Okay, so as you can see here, the threshold is basically we store anything that is above the threshold. So we sort the brighter values, right? And in Kim's code, he actually has an option for you to change the modes, whether it's bright mode or a dark mode. But what I'm going to do, just to show you how would you switch it, right? Basically, it's the conditional statement, which is here. So instead of doing, if it's greater than the threshold, we just do the opposite. So if we do less here to find the start Y, and then we just need to change this to greater to find the NY. So if I click run, it's kind of hard to see, but you can see a little bit that the darker side are being sorted, right? Okay, so now what I'm going to do is I'm going to copy the sort column function and then basically just sort the row. Very similar, right? But we basically just need to change. What do we need to change? So let's do row here, change this to Y. So all the Y's will be X, right? So X is less than image of width. Width here. All of these are the same. Nothing changes. We find start X instead of start Y. And we want to increment X, not incrementing Y, right? And X, so everything will be X instead of Y, but I just want to make sure that you also change it here when we find the index, right? So instead of X here, it's going to be I, and then Y is going to be fixed. Same thing here, X, X, and then this is I, and then Y is fixed, and then we increment X instead of Y. All right, let's go to here. How about I comment this out first? and then do one where we go through the Y instead. Sort row by Y. And okay, so we did the, actually, we can just increase this to 100. All right, let's try it. Start Y is not defined in 141. 141, that is correct. It has to be start X. Uh-oh, it's crashing.
A few moments later.
All right, so the program crashed. So I'm not sure exactly where I did incorrectly, but basically like you saw earlier, I copy and paste the sort column function and then change it to row, and then just making sure that I changed all the values that should be Y into X. And now, as you can see here, the image is being sorted by row. And what you can do is you can sort both, right? If I uncomment this, and then it is being sorted both by columns and by rows. Looks really nice. But before I go, I want to also show you how to animate this. So basically, how can we see it being sorted by column or by row, right? Which is actually in Kim's original code. And it's actually very easy. And we're not going to do no loop anymore, right? Because we want it to run multiple times. So as you can see here, I already moved the image.loadPixels inside setup, because before it was inside draw and we have no loop. So it's only being loaded once. But basically, we only need to load the pixels once, right? Because the image stays the same, but we want to update the pixels continuously. So the update pixels is still here. Actually, let's delete this so that it's cleaner. And instead of looping through everything using a for loop, we're going to be looping through the draw loop, right? So instead of doing this, we're going to set current column as a variable. So let's do current column starting at 0. Then we're going to increment it by 1 and write a conditional statement that says if current column is greater than, right? Yeah, we want it to be after, yeah, greater than image.width, then we're going to set sorting done to be true. Then image.pixels can be here. And yeah, let's try this. Nice. Alrighty. So that is it. You see, oh, there's an error. Color was, let's see what's wrong. 43. Maybe, I think if current column, yeah, is greater or equals to. All right, so that is it. You see different ways that we can sort this by columns, by rows, with brightness that is above or below the threshold, and you can mix and match, and then you can actually sort it. What if you don't sort it, basically, right? And add in different colors and maybe use that color in different shades. There are a lot of possibilities, and I'm excited for you to try this one. The effect is really cool, and check out the original code by Kim Asendorf, and I'll link everything down below. So give this one a try.